Hi everybody. Today we're talking about one-step equations. Write this example down at the top of your paper, your notes. 3 plus x equals 7. Then subtract 3 from both sides. Subtract 3 from the 3 because we want to get that x by itself. And when you take 3 away from 3, that leaves you with the 0. So now the x is by itself. And then subtract the 3 from the other side. It's 7 minus 3 equals 4. We'll go into this in a little bit deeper detail in just a moment. But if you go ahead and write that example down now. Great. Pause it if you need to. I'm going to move on. Okay? What does an equation tell us? An equation basically just tells us that two expressions are equal. So if I have 3 plus x on one side of my balance and 9 on the other side of my balance, and they're equal, they're balanced out, what must x be in order for this scale to be balanced? Okay? Make sure you write down this definition. Okay, here's a bit of notes. If you need to pause, that's fine. In order to find out the value for x, you have to get it by itself or isolate the variable. Okay? So 3 plus x equals 9. X is our variable. We need to know what x equals. So that means x has to be on one side by itself, and all the other numbers and how their operations work out need to be on the other side so that we can have a value for x. Now, because the 3 is connected to the x with a positive, with a plus sign, that this is an addition operation. In order to disconnect the x from the 3 and the plus, you have to do the opposite of add or subtract. So in the red here, you see I have my original equation and the original operation, which is addition. And now to undo it, I'm going to undo it in the blue, and then subtract. And what am I subtracting? The same thing from both sides. So I'm going to subtract 3 from the 3 plus x, and I'm going to subtract 3 from the 9. The reason why we subtract 3 from both sides is so that we can get 0 with the x, on the side with the x. We want to get the x isolated, okay? Now, this is not, I don't have a slide for this, but be sure to write this down in your notes. There is a place for this on your notes, okay? This is called the identity property of addition, that when you subtract something from itself, it gives you 0. Or if you add the opposite of something, of a number, if you have a number and you add its opposite, it will give you 0. Or any number plus 0 or minus 0 gives you that same number. Okay? Here. And we add 3 negatives or take away 3 positives, however you want to look at it. Adding a negative and subtracting a positive is the same thing. Okay? You're going to get 0. Each red dot will cross out with the blue, will cancel out with the blue dot. And so you're going to get three 0 pairs essentially on one side. And whatever you do to one side, of course, we know you have to do to the other because this is an equation. Okay? If you want to keep it balanced, then you have to do the same thing to both sides if it's already balanced. So we got to subtract 3 from the other side. When we subtract 3 from the other side or add those 3 blues and those 3 negatives, we cross out each one, each 0 pair, but we're still left with 6 on the other side. So x must equal 6. X must equal 6 because if we are able to cancel the same thing on both sides, what are we left on the left hand side? We're left with x, and on the right hand side we're left with 6. So x must equal 6. Okay. So now what I need you all to remember, first of all, the goal is to isolate the variable. Okay. You have to solve for x. That's the whole point here, is to solve for x. And so when we solve for x, it has to be by itself. Okay? And so to keep everything on both sides equal, whatever you do to one side, you have to do to the other. And the whole point of moving things around is just first we want to get the x by itself, the variable by itself, and then we want to simplify what's on the other side of that equal sign so we get an accurate value for x, or whatever that variable is, right? So we're going to add 7 to both sides in order to get the x by itself in this example. Add 7 to both sides, okay? You can see in the darker blue, I'm adding 7 to negative 7, which because of the commutative property, because of the identity property of addition, we're going to get 0. And then we add the 7 to the other side to get 11. X equals 11, okay? Remember, two basic things to remember. You have to isolate the variable, and you have to do the same thing to both sides. Okay? Great. The last thing I want to mention is that addition and subtraction are opposites. Okay? So here you see in the green, I have 3 plus n equals 8. So in order to get the n by itself, I'm going to have to subtract 3. Why are we doing opposites? The opposite operation. Because of the identity property again. When you subtract a number from itself or you add two opposite numbers, you're going to get 0. And if you add or subtract 0, you're going to get the same number you started with. That's the identity property of addition. Okay? And because addition and subtraction are opposites, it goes for subtraction as well. Okay? And so we subtract 3 from both sides. On the one side we get n equals 5. On the other side we're adding this time because we have a subtraction sign in our problem. So we're adding on the blue side. And we add 4 to both sides, so we get s equals 10. You can always check them. Plug in 5 for n. Is 3 plus 5 equal to 8? Why, yes it is. Plug in 10 for s. Is 10 minus 4 equal to 6? Why, yes it is. You're going to do the same thing to both sides. Okay? And whatever it is, whatever that thing is that you do, it has to be the opposite of the operation that's in your equation. Because if I were to add 3 to a positive 3, that's not going to give me 0. If I was going to take 4 away from a negative 4, that's not going to give me 0. Trying to get 2 0. Alright? Cool. And so, just as well, I wanted to show you that multiplication and division are also opposites. So if the 4 is being multiplied by x to give me 24, then I have to divide by 4 in order to get x by itself. Now this is the identity property of multiplication. The identity property of multiplication says anything that is added, anything that is multiplied or divided by itself will give you 1. Or anything that you multiply or divide by 1 will give you itself. So the identity factor in addition is 0, plus or minus 0. In multiplication, the identity factor is 1 times 1 or divided by 1 to give you that same thing. Okay? And so on the division side, we're doing the opposite of division, which is multiplication. And so since we're dividing the n by 8, then in order to get n by itself, we have to multiply the n divided by 8 times 8, because 8 divided by 8 is 1. And then going with the n, so just the n equals 2 times 8. So let me recap that. In order to get a number that is being multiplied by a variable out of the way, so that variable can be by itself, you need to divide by that number, because it'll just give you 1, which is the identity factor. Anything divided by itself equals 1. Do the same thing to both sides. The x is left by itself. 24 divided by 4 is 6. On the division side, if the 8 is dividing the n, in order to counteract that operation, you have to multiply. In order to counteract a division problem, you have to multiply. And so 8 divided by 8 leaves us with 1. or the n by itself, the 1n by itself. And then because we multiply by 8 on one side, we multiply by 8 on the other side. So we get n on one side, 16 on the other side. That's pretty much it. I probably will do a video soon. If you guys having trouble with the idea of the properties, the identity properties, I may do a video on that depending on who needs a recap on that. But that's basically the end of this. So now what you need to do is make sure that your notes are complete. Please be sure to go back if you need to, especially to that one side that had all the writing. Make sure you have what you need in your notes. Be sure to pause here and do that. Make sure that you try the examples that are on the notes. That's how we will start off class. And that's where I'll start off with any questions on one-step equations.